Hello folks, it's me Tabo and welcome to another tutorial on Three.js. Today I'm going to be showing you how to create this butterfly over here. Now we'll be creating this using a circle geometry and some spheres to create the sky. And one of the features of the project is different post-processing effects. Now at the moment it is a raw scene, but you can also view the scene with different post-processing effects. We've got our bloom effect. We've got our dot effect. We've got our sobble effect, and last but not least we've got film effect. So all of these will be built into the project. So without further ado, let's just jump right into it. Okay, so right in front of us we've got the bare bones of our code. So these are the modules that we'll be using for the project, and I'll just be taking you through the basics. So this is a basic setup. Like usual, we've got our renderer. And once again, this is not a newbie tutorial. So if you're a newbie, then check out the link in the video description for my beginner tutorials on Three.js. If you want to follow along, please, you're more than welcome to do so. You can still learn something. So we've got our basic setup by camera using our canvas, and then we've got a render pass. So this is what we'll be using for the different post-processing effects. So the different post-processing effects we'll be using here will be bloom, a dot, film, and sobble. Okay, so this is just the basic setup for all of these things, and yes, that's it. So in order for us to now get started with the project, we're going to need to create a few things. So over here, then we're going to start by creating a capsule mesh. Now the capsule mesh will be the mid part of our butterfly, and then over here, then I will create circle geometry. I will give it a radius of 2, and then I will make the segments into 3. Now this will make it look like a triangle. Okay, according to the number of segments that you put here, it will alter the shape. If you wanted to get a hexagon, you would make it 6. You get the point. And so I create one, and then I create a second one with different materials. So the material colors will be different. As you saw in the examples, we've got green and blue. So this is what that represents. And then once we're done, then we're going to create clones of both of them. And then next we'll create our sphere geometry, and we will give it a radius of 70, and we're going to use that as the sky. So along the vertices, this is where we're going to position the different spheres, which will pose as the stars in the night sky. And then next up, we're going to create two groups. We'll call each one wing group 1 and wing group 2. Wing groups will just be exactly what they describe, the wings. So one will be the left wing and one will be the right wing. So we're just going to take the geometries and group them together. Okay, next then I'm going to create an object 3D, two of them. One will be the left wing rotation and one will be the right wing rotation. Okay, so next up we'll create the butterfly GRP, which is just butterfly group. It is a group, and inside of it we're going to attach the left wing, right wing, and the capsule mesh. And then next up we will take the left wing rotation, and inside of it we're going to attach the wing group 1, and on right wing rotation we're going to attach wing group 2. And then over here we're going to take wing group 1, inside we're going to attach circle mesh 1, we're going to attach circle mesh 2, and then in wing group 2 we're going to attach circle mesh 3 and circle mesh 4. And so next up what we need to do is to get the position of the different vertices on the sphere that we created. So we're going to create a variable called position, and this position will be assigned the position array within the sphere geo attributes position. So the position is basically an array. It's a float 32 buffer array which holds the different values for the different vertices which are on the sphere. And then next we'll create an array called indices. So indices will basically take the different arrays, because how the arrays are created is that they're not all bundled together, because this is, each vertex is a vector 3 value, right? It has an x, y, and z, but in the position all the different values are put in an array. So the indices is basically taking them and grouping them into 3s, which is x, y, and z. And so that's all that we're going to be doing. So we're going to go through the array, create a vector 3, and then inside then we're going to give it the different values, which are just the positions of the different arrays. So that's your x, that's your y, and that's your z. And then once we're done, then we will take position and then we will push it into our indices. So now we will have an array which holds the different vector 3 values which represent the position of the vertices on our sphere. So Next up, we will be creating a curve. As you saw, the animation, the butterfly is not actually moving. The wings are flapping, but it is stationary. It is in one position. Only the camera is rotating around the butterfly. So now we're going to create a curve, and this is the curve that we're going to be using. We're basically going to use it like an animation path. So the camera will just be rotating along this curve as a path, and it will be facing the butterfly the entire time that it's rotating. So that's what that is for, is to animate the camera. So we'll create a catmull rom curve 3, and we will give it these values, and then we will make the curve type to centripetal, and we will make the curve closed to true. Okay, so next we will create a tube geometry. Okay, we're gonna use a tube buffer geometry, and then we will feed it this information from the curve. So we're gonna use the curve, and then we're gonna give it these different settings. Now, just if you want to know what these settings are, this is what they represent. So this is our curve. So we've got our tubular segments, we've got our radius and radial segments. So this is what that is: tubular segments, radius, and our radial segment. And then the last part is a boolean, so we want it to be true. We want it to be closed. Next, we create a material. It will just be a mesh basic material. Well, this is not really necessary, to be honest, because we're not gonna see any of it, but because I use this from code that I used before where it was visualized, I actually have made posts of it where the camera is moving and there's a grid of geometry. So that's what that is for. But in this particular example, we're not gonna need it. We're just gonna use the information from our tube geometry. You can just copy that. If you want, you can also add this to the scene, and then you will see the effect that it will add. But for this particular tutorial, it's not really necessary, but create it as it is here. And then we're going to create a mesh. We're going to use the tube geometry and tube material. And then here I'm going to create a variable called clock. We're going to use a 3.clock. This is something that we're going to use for the animation later on in our render function. And then I'll come down here. I mean, this doesn't really matter, the particular order in which this is done. I'm just following the code that I created as it is, just to avoid confusion. But there is no particular reason why I've chosen to structure the code the way that it is. It doesn't have any consequences if you choose to do it differently. Okay, so I'm going to create a variable called orbs, and this variable is what's going to contain the different spheres which will be positioned along our vertices, the vertices of the bigger sphere, which is supposed to be our night sky. So then we create a for loop, and we're going to use the length of our indices. And so for each and every loop, we will create an orb, and we will give it these different values, and we will add the orb to the scene. And then we will create a position which will be based on the indices. So here I'm just taking a random indice. So I don't want the stars to be positioned in line, because then it's going to look fake. So I want them to be randomized. So I'm just taking random values from the entire array where we can position our orbs or spheres. So I'm creating the position, and then I'll say if position exists, then we can set the position of our orb according to the position of the indice value. Okay, and then here I'll create a variable called scale, and this will just hold a value, a scale value, which will be a random number between 0 and 10. And so we will take this, and this will be the scale of our. Now that I think of it, it actually doesn't make sense that it is 0. I should actually make it +1. Yes, that's my mistake right there. So that we don't get 0, because if the scale is 0, then it doesn't make sense, because then the sphere is not visible. Okay, so we're getting a random number between 10 and 1. And so we will use that scaling to set the scale of our orb. And then after that, then we'll take that orb and push it into our orbs array. Now the reason why I had done that was originally I had intended on creating some kind of animation with the orbs, but that I decided not to do because it was gonna take way too much time. I can save it for later because I can still add on to this. But for now, that's what the initial idea was. Okay, so now that we are done with that, then we will add all the other stuff that we created. So we will add our butterfly group. It says butterfly. It's supposed to be butterfly. So we'll add our butterfly group to the scene. We'll add our camera, and then we'll add our tube mesh. Okay, so this is the most important the most important part, because it is important that everything here is correct, because it's rather complicated. One thing that I will also do is once we're done with this, I will also show you how to use Three.js's editor, because to position all of these things with code is quite tedious, because you have to then do a lot of typing up until you find the right position, where if you use the editor, then you can just use the controller, the widgets, to basically position or to set up the scene the way that you want it to be. And then you can then export that scene as a GLTF, and then you can start coding the fun parts, you know, like the interactivity and the animation and that sort of thing. But you don't have to spend a lot of time just positioning things in space. That is actually a waste of time. But this is what I did here, but I will show you a different method because I think that is important too. So over here, then we've got the different settings. Butterfly group, the scale is set to 0.5, and its rotation on the x-axis is math.pi times 0.5. So basically follow these settings as they are. Position y is equals to -1 for circle mesh 1, circle mesh 2 position y is 1, circle mesh 3 position y is -1, circle mesh 4 position y. Well, you get the point. I'm not gonna read everything, but just make sure that you just have these values as they are, otherwise you will run into problems. And because you did not create this yourself, it might be a bit of a mission to get everything to line up correctly. And so we will create a camera position. Now in the end, this camera position will not be necessary, but if you want to turn off the animation and then just scroll around your scene just to have a look at the object in space, then you can use these positions. So for now, I'm just going to include that just for simplicity's sake. Now inside our renderer, we'll say the camera.lookAt, we'll set it to look at the butterfly group. And so inside here, this will be where we're gonna set our time. We've got different times here. We don't actually need all of them. I had created these because I was trying to experiment with the different settings. You can follow along, try both of them, but we created time, and then we get the elapsed time, and then we create a loop time. This will just determine how fast or how slow our animation is. And so then we're gonna create a variable called position, and we're gonna assign it this value. So we're gonna say tube mesh dot geometry parameters dot path, and then we're gonna say get point at t. So we're gonna use this to get that point. And so same here, as it does the same thing, just using different values. And then once we're done with that, then we can then copy the position into our camera. So we're going to use that position and copy it to the camera. So now the camera will be following that path. Okay, then next up, then we'll take our butterfly group, and then the position y will be equal to math sine time times 2. So it will be moving up and down. It's very subtle, so that will just be animating up and down in the y position. Okay, we've got our left wing rotation on the y-axis, and then we're going to animate it using a math sine times, well, using the time times 300. The reason why it's bumped up so high is to control how fast it is. Just this value is not enough, so we need to bump it up. Okay, so we do the same here, but we just do in the opposite direction. And then once we are done, then we can just render our scene. Okay, so let's have a look, see what our scene looks like. And so as usual, I'm already running the server, so you don't really need to run a server. So you can just open the file on your browser and it will play. I usually just use that because it makes it easy for me, because when I'm importing a scene or any models, then I need to be running it on a local server. So I just do it so that I don't run into problems. So whatever it is that I'm doing, it doesn't really matter. I can just still view my work. Okay, so here we go. So here is our butterfly. Doesn't that look like a happy butterfly? So now if we want, then we can then view it using the different post-processing effects. And all that we need to do is change this over here. Okay, for our bloom post-processing, we just called it composer. Okay, so if I say composer, see, so there is our bloom effect. And then if I say dot composer, then there we go, we have that, and we can do sobble. There we go. So yes, so basically that is how you create the scene, and you can have lots of fun with it. See if you can create more butterflies in the scene, whatever you want. As you can see, also if you look at my night sky here, some of them are not so random. Like for instance, when you see like these lines, you know, that is, well, what I was avoiding, but it's not perfect, but it still illustrates the point. Yes, I think we're good. So yeah, with all that said, love and peace. I hope you enjoyed, and please like, subscribe if you like the content that I'm creating. Hit that notification bell if you want to get more notifications when I put out videos. Like, with all that said, please, love and peace. Okay, I appreciate the support. I'll be presenting more good stuff like this. So yeah, love and peace. Enjoy. I'm out.